Great. So good afternoon, everyone, and welcome our webinar that will be focused on artificial intelligence today. And yeah, at the end, we are quite lucky that we are both here with Richard because there was horrible wind in the Czech Republic, and there was outage of electricity on the place where Richard is located. So we are lucky that we can be both of us here. So. We will be here too, and the subtitle of our presentation is why you should start with the artificial intelligence today because your competition started yesterday. Hi, Richard.
Hey, Peter, and hey, everybody. My name is Richard. I'm a machine learning engineer here at CN Group, and I'm working with Peter and our amazing machine learning team on some really exciting artificial intelligence projects. So I'm really thrilled that we can discuss together the topics with you.
Great. Thanks, Richard. And I just said my name is Petr Polak, and I'm responsible for AI and BI project here at CN Group. And today we'll be discussing a lot about artificial intelligence and machine learning, especially these 5 points we would like to go through because we found them important these days. And definitely the first one is about trends, where we are going with the machine learning these days. Second, we would like to show you or discuss the applications of AI in different industries. And of course, the same with how we can map business strategy to the AI strategy, because it needs to be somehow synchronized, and we have some hints how to do that. As well as Richard will show you his experience with some case studies that he experienced. And last but not least, we sometimes facing with our customers that they are not sure how to start with the machine learning because it can be quite different from hardware or software development. That's why we created somehow a cookbook how to start with such a project, which can be useful as well. We'll try to be as practical as possible. And please, if you have any question, let's do it more interactive. Ask anytime you want to ask about anything, and we can discuss it even during the presentation. So just few words about CN Group itself. The CN Group is a company that is on market for more than 27 years. And we have now almost 400 employees in 5 production locations. We have headquarters in Prague, but we are also located in Slovakia, in Bratislava, and in Romania, in Bucharest. We have our 95% of our project are managed in Scrum methodology. So we have now 17 plus years of agile experience. And we have like more than 100 projects on a yearly basis. And our customers are in an overwhelming majority, I would say, in Western Europe, especially in DACH region and Scandinavian region. So that's all about the CN Group from that perspective. From the service perspective, we are trying to do everything under one roof, which means that in case of IoT, for example, we can prepare mechanical design engineering of the product, as well as the electronics and embedded, plus machine learning, that will be a main subject today. And with the cloud solutions that are now available on the market, especially Azure, AWS, and Google Cloud, we can even provide that part of service, as well as the front end part of the product, which is web or mobile application. So that's something that we are able to do. Today we'll focus on machine learning, and let me start thinking together. Let's think that we can imagine that we could transform from an era of people doing work supported by machines to an era of machines doing work guided by people. What that really means? That means that any big problem can be transformed to big data problem that we are ultimately able to solve. We can think about COVID-19 vaccine, for example, something that is really current these days. Was developed by AI or was driven by AI as well. Or we can think about self-driving cars. Yeah, we can say that on European roads we can't see autonomous driving that often, but the main reason are regulations. The technology is basically ready. So that's like few examples what can be used and how AI can be used. The thing that is important to distinguish is that machine learning is basically providing completely new programming paradigm, because now in classical programming we have as the inputs we have rules and data, and we have answers as the outputs. But in case of machine learning, it's different. We have data and answers as the inputs, and rules are basically outputs out of it. That's why we can say, and it's written in the bottom of the slide, that machine learning system is trained rather than explicitly programmed. And these are like big difference. And now let me ask, and we can try if your microphones are working. Tell me any example of AI you use on daily basis, anything that is coming to your mind. Maybe we can like discuss slightly what is like coming to your mind. It can be anything. Any idea, an example? Okay, there are just two options. The microphone doesn't work, or you don't have any example. So I will provide one or two. One is definitely chatbot. That's something that you probably coming across all the time when you use some web service. You try to communicate with some companies like from telco or even from banking systems, and you can find chatbots anywhere. Or if you have iPhone or any new smart home that uses face recognition, that can be another example of AI that is used all the time. And I have even one message here. Thank you, Mahdi. Clustering algorithms used for automatic data preparations and cleanup. Yeah, okay, means Richard definitely know what it's all about. Thank you for that. And this practice was just about the fact that we are not talking about something that is in front of us. We are already living in AI world in a way that we use these products already. And let's now take a look at some basic terms, Richard, that will help us to find a difference between these terms.
Definitely, Peter. Well, let's start with the definition on the next slide, what we mean by AI, machine learning, and deep learning. These are the most common terms in our industry. Let's start with artificial intelligence, because the goal of AI here is simulation of human intelligence in machines to make them think like humans and mimic their actions. And then there is a subfield of artificial intelligence called machine learning. And it basically consists of all the algorithms that are able to learn without being explicitly programmed, as Peter mentioned. And lastly, there is a subfield of machine learning called deep learning that is based on artificial neural networks and is one of the best machine learning techniques capable to learn very complex tasks.
Okay, Richard, that sounds great. Can you show us the example of difference between machine learning and deep learning, just to be sure that it's clear?
Sure. Well, on the next slide, let's clarify the terms. Here is a simple example that many of you might be familiar with from Facebook, Google, or other companies. It's image recognition or classification of a dog and cat using machine learning and deep learning methods to recognize them. Now, this is a very simple application, but we can easily apply the same strategy to many other applications like face recognition or object detection of vehicles and cyclists on the road for autonomous driving systems, or even other seemingly unrelated applications such as sound classification used in customer services and manufacturing industry. Now, in order to do object classification with machine learning, what do we need? We need inputs or images. And we also need to tell the computer what these images represent, because it has to learn it first. So we label these images saying this is a dog and that's a cat. Now on the next slide, let's have a look on the steps in machine learning and deep learning that we would take in order to classify images. In classical machine learning, the first step is what we call feature extraction. And this is essentially looking on images and trying to figure out what are the signatures of the dog's ears or the dog's eyes. Here, for instance, we could say, well, eyes look like small circles, which is a feature. And we would go on and on searching for signatures of the object. And by doing so, we would extract all possible features that would help us classify the image. Now, having all these features, we can feed them into the machine learning algorithm, train it, and let it classify any new images of dogs and cats that the system hasn't seen before. Now, let's compare this with deep learning. Here, the feature extraction step you saw is almost completely done automatically by the neural network. The network basically says, show me a lot of images of dogs and cats, and I will automatically learn the signatures to recognize either of them. And this is in essence how machine learning and deep learning differs from each other.
So Richard, can we basically say that machine learning is more manual and deep learning is done much more automated way, correct?
Yes, that's more or less correct. Basically, deep learning gets rid of almost all the steps of feature engineering and automates it.
Great, great. However, deep learning is trendy, like, let's say, last 10 years, but he was here even before, let's say, last 30 years. And the reason why it became so popular lately was then that there are like three pillars why it's happening right now. And the first one are publicly available data sets provided by companies like Facebook, Google, Microsoft, AWS, and any others. And thanks to them, you can train your model, you can get a great prediction capabilities thanks to that, and you can use this large amount of data for good for your deep learning techniques and for your deep learning neural networks. So that's the first part. The second part is hardware. Deep learning models requires like large amount of computations, and thanks to companies like NVIDIA or AMD, we can like now using that complex deep learning techniques. And definitely all these investments in game industry came to benefit the AI and machine learning community. So that's definitely important as well. And last but not least, deep learning techniques themselves. They were here all the time, but they were like too simple because the complex models were not able to drive on hardware that was present that time. Right now, it's much better, and thanks to that, deep learning techniques are now in majority of cases is beating classical machine learning approach. It's not 100%, but it's becoming more and more thanks to data we have available. So that's more about deep learning itself, why it's so popular these days. However, that's just some new term we now use, right? But our main question should be how we can really transfer deep learning techniques to real business, to real life. And that's something we will go through. But before that, let me ask you if you have any question, or you can even write it to the chat if you want, or if you have any direct question right now, please feel free to ask. All right, if nothing now, please feel free to ask even your questions to the chat. And let me back to the presentation in a way what I just said before. So let's take a look how we can like extract value of deep learning to the business. The first main benefit of deep learning techniques is that we can use it for market growth. It can increase our customers and users or increase their conversion. And the second like general benefit is increasing the efficiency. It can drive efficiency of your processes. It can reduce time waste and costs related to the business operations. But let's go even to some concrete examples. It can be even better. So the first industry where AI is adopted these days is definitely retail. There's like many examples we can take a look. And one of the examples from retail can be a company called Netflix. I guess you know that streaming company that is offering movies and TV series. And there was a $1 million prize for a team that can come up with the best prediction algorithm. That's what I did it. And that's why these days we have this great prediction algorithm. And thanks to that, we are able to really enjoy the movies that are most likely popular for us or attractive for us. So that can be one example. And I know, Richard, that you have one more example about demand forecasting. Am I right?
That's right. Well, on the next slide, here's one interesting example. It's demand forecasting, which is often used in the car or bike sharing industry. And in this case, this example, we are trying to predict the number of bikes that a bike sharing company needs on the road to meet customer demand. And it's based on past rental data. It's important to say again that the best time to start any machine learning project is when you have tons of data, so much in fact that it overwhelms you. This is the case here in the example. We have collected a lot of data points, capturing the right rentals by the hour. Typically, you want to collect as many various data as possible. In deep learning, we call these data inputs or sometimes features. Now, this data set includes inputs like time or date, wind speed, temperature, and humidity. which are all relevant for bike rental predictions. If you are from banking or finance services, think about all the user data you have available that could be used for machine learning predictions. And if you are from manufacturing industry, there are lots of sensor data you can leverage as well for machine learning predictions. So now that we have the inputs, the deep learning model also needs to know what the outputs are. In this case, number of bikes rented.
So this is, Richard, similar to dogs and cats example from previous slides, right? But just now the output here are riders, not cats and dogs.
That's right, indeed. Well, we need some labeling if we use supervised machine learning, but without going into the detail, yes, we need to get the outputs as well. And now having the data ready, we can take the inputs and feed it into neural network and let it make predictions. The model predicts 41 riders, and to make sure that the predictions are correct, we will compare it with the outputs from the data set. If the prediction is wrong, we need to update the model, and once the predictions are correct, and we are confident that the model works well, it's time to deploy the model on new unseen data. This looks like this is the end of the story, since we are getting great predictions, but we always have to ask if there are any edge cases that were not included in the training data to train the model. And if this is the case, then we can end up with, I would say, wrong predictions looking something like this. What do you see on the top? What's wrong with these predictions? The model hasn't seen and haven't been trained on data during Christmas time, and we are getting wrong predictions.
So you take this finding, train the model again, and then the model is able to predict number of riders even during the Christmas time, right?
Exactly. The solution is retrain model or your machine learning model on any edge cases and unseen data, because the model can only predict what it has seen in the past and then generalize it on it.
Great, got it. All right, thanks, Richard, for that. And let's move to other industries where AI can be used. The second vertical, I would say, can be healthcare. Healthcare has one characteristic, that they are literally swimming in the data, which can be, of course, tricky and challenging, but at the same time, there is big opportunity to implement machine learning system to make sense of the data. So definitely healthcare is where AI is used even now. And I already mentioned COVID-19 vaccine, where AI is used quite widely. The third industry we should mention is financial services, definitely, during like risk analytics or fraud detection. These all parts are definitely important for AI as well as the manufacturing. And Richard will mention predictive maintenance in a while, and there's many other examples where AI can be used. And last but not least, automotive, agriculture, and robotics, the same thing here. And here's the one interesting thing. There is one machine learning application used across all industries, and it's called anomaly detection. Anomaly detection represents the situation when something is not standard in a process. Doesn't matter whether it's fraud in finances or some machine in manufacturing is broken, or, for example, car is broken. And that's something that we can take a look even more deeper. Richard, will you show us some example here?
Yes, sure. Well, one of the applications that heavily utilizes machine learning to detect anomalies is health management and failure prediction. If you think about any product, such as a vehicle, industrial robot, or even your washing machine, all these products go over time to the end of their life cycle. And the aim of health management is to extend the life of those products. There are few possible maintenance strategies that companies follow to increase reliability and save cost. The first one is reactive maintenance, where the product is used until the end of its life and where repairs happen only after failure occurs. And this is okay if you are talking about a light bulb, which you just take and replace without any consequences. But if you think about a very expensive and complex system like your vehicle, then you can't risk running it until failure. That would be too expensive and could be dangerous as well. Now, there's another strategy called preventive maintenance. For those systems, I would say more complex systems, companies implement different strategy to prevent the failure before it occurs by performing regular or scheduled checks on their products. One of the challenges here is to figure out when to do preventive maintenance, since you don't know when the failure occurs. That means you don't want to be too late, as well as not to do the repairs too early. And lastly, there is a predictive maintenance strategy, which is a proactive strategy that analyzes data in real time to suggest maintenance by spotting early signs of equipment failures before they develop into costly incidents.
So that means that predictive maintenance can save costs, right?
That's right, but it can also save lives, which is one of the reasons for implementing predictive maintenance in products where safety is the most priority, like in airplanes.
Mm-hmm.
Okay, let me briefly show you what are the steps to implement predictive maintenance on an example of industrial robot. First, we need to collect data. Usually there are various types of sensors that we could make use of, but for now, let's just consider vibrations. So here is data we would collect when the robotic arm is moving in normal operating conditions. And here we collect data while the robotic arm is having vibration issues, and that's what we will call faulty data. Capturing all this data will help the machine learning algorithm to learn and later recognize if there are any issues with the industrial robot. Makes sense so far, Peter?
Yeah, it does. I'm just wondering, how do we collect the faulty data? Because I guess we don't want to break the machine in order to get the data.
Well, that's right. Most of the time, you will collect only data from the machine operating in normal conditions, and you won't be able to collect the faulty data so often, or sometimes not at all. If that's the case, you can make use of something called digital twin, which is nothing but a virtual representation of the machine that you are monitoring. And this enables two things. First, generating new synthetic data, and mainly simulate the machine in faulty state. That means when something is broken without making any damage to the real machine.
And that's an interesting example. And can we use the same digital twin in finance, banking, or any other domains?
Sure. Actually, the use of digital twins is already common in a number of industries. It's used in healthcare to model biochemical processes and develop new drugs, or even to create digital twins of human heart for clinical diagnosis. In finance, some banks have already experimented with creating lending outcomes, or I would say digital households to explore different lending outcomes.
I see. Thanks, Richard, for that. And now let me go to the question to you. If you have any experience with anomaly detection or digital twin in your business, because it can be quite frequent thing, but maybe not. So you can just write or tell me, or even raise this virtual hand here, if you have any kind of experience with that. All right, looks like no experience in that. I think it's coming more and more to the real business. Richard has wide experience with that in manufacturing, but it can be even in finance, as we mentioned, and I think it's coming more and more to the real business. So that can be like a good example of AI used there. And let me now take a look to how we can really choose the right AI strategy for the business objective, because it always depends on your business objective. We picked 3 strategies, but there is basically more and more strategies between these 3. They are like the best examples of how and what strategies can be used. So first one here is the strategy that I personally call the AI product off the shelf. It's something that is already on the market. You can take it from the market and integrate it to your solution, to your system. The great example can be optical character recognition, something that is already solved, and maybe you have a business where you can use this particular thing. So it's really fast. You don't need that much effort or customization, but of course that everyone can use it, not only your company. So that can be like one downside. The second, called transfer learning, is model or machine learning algorithm that you can use the way that the algorithm already exists, but you need something specific in that and that's why you need to adjust that model. Yeah, one example is the quality control in production, as you can see on a picture, on the production lines where you would like to classify a new object. like the broken crown cap in our case, that the model has never seen before, and just train again the model in order to include this new class as well. So basically the model is ready, you just need to enrich it by one more classification called a broken crown cap. Of course, that speed now here is lower, effort and customization is higher, but your competitive advantage can be bigger than in the first strategy. And the third strategy mentioned here is building the end-to-end AI solution. The example can be voice identification in fintech, or any other example that you can think of and you don't know or you're not aware that anyone else is using. So you need to do it yourself. The speed is like, it can be like long to develop such a thing, and there's like really a lot of effort and customization, but at the end of the day, you are much more competitive than with the previous strategies. And now when we take a look at the knowledge of people needed for these three strategies, the first one is, and it can be some pre-trained machine learning API, the first one is that one when we don't need machine learning engineer at all. We need integration engineer who is able to connect that together with your solution. In a second strategy of transfer learning, you need machine learning engineer as well as the integration engineer. And even in the third case, you need both guys plus machine learning researcher as well. So these three are super important for the third strategy here. And these strategies are nothing without real and practical business or case studies. So Richard, can you show us your experience with AI projects?
Definitely. Well, we prepared two case studies that we would like to share with you. And the first one, or the focus of the first case study, is on computer vision, which is applied to a very special infrared sensor from Panasonic, a sensor that is smaller than a €1 coin and is capable of detecting hot thermal sources such as objects and people, even though its resolution is only 8 by 8 pixels, which is considerably low. Now, the challenge in this study was to detect and count people without exposing their identity, which makes it a very secure IoT device at the same time. Our solution we develop is based on machine learning, specifically on deep learning algorithm that can detect and count more than 10 people. At the same time, the algorithm runs directly on the hardware without a need to transfer data to the cloud for further processing. Developing machine learning system that can detect and count objects using a camera, such as those on your mobile phone, is not so hard these days, but doing the same on a hardware with extremely low memory and low sensor resolution presents a real challenge that we were able to solve in this project. Now, the applications of such an IoT system are many, and just to name few, for instance, in smart homes, controlling your air conditioning system, monitoring if and how many persons are present in the room, is helping save your utility bills by adjusting the aircon operations. And on the next slide, you can see a sort of high-level overview of the machine learning system without exposing the details of the algorithm. Now, behind the box called FCNN is a truly customized neural network architecture that accomplishes two things. It classifies whether an object is detected on the scene, and it calculates positions of detected objects. On the right side, you can see the sensor output with bounding boxes in red representing detected objects. And just for validation purposes, at the top is a video stream with people walking and sequentially leaving the room. This should give you a good idea of what such an infrared sensor with machine learning algorithm is capable of. Okay, now let's have a look on the second case study. The previous study was focused on computer vision. This case study is about sound. Here, a machine learning system is applied to automotive industry, where the goal as well as the challenge is being able to recognize and classify different vehicle components from sound recordings. So imagine you are a technician in a dealership and a customer comes in complaining that the vehicle makes unusual noise. So what's your response? Usually you will need to examine the vehicle on the road or in the garage, and based on your experience, you either can detect what's going on, or in very many cases, you simply have no clue what's causing the noise. Now the customer is still waiting, time is running, and so the customer starts to be less and less happy with your performance. I don't know, Peter, have you ever experienced long waiting times or wrong repair in a car service?
Definitely. I think almost everyone experienced that. Not long waiting time, but unfortunately wrong repair.
Yeah, I got similar experiences as well. Now, the solution that we propose here is a sound classification system based on deep learning that can recognize whether the damage is related to your gearbox, electrical powertrain, or other components. It uses the power of signal processing and deep learning to solve a phenomena called cocktail party problem, which means focusing your attention on one person when multiple people speak at the same time, which luckily your brain can solve, but we had to deal with that. Coming back on what Peter mentioned at the beginning of the presentation, that deep learning requires a large amount of data, this is exactly the same case here. To achieve high accuracy, we need lots of various data. Maybe to wrap it up, the idea here was to speed up the process of detecting damages on vehicle components from sound recordings, facilitating the work of technicians and dealerships.
Great. Thanks, Richard, for these two examples, I think, and it can get a better picture how it can be used as well. And now let me show the path of machine learning. I call it sometimes the cookbook, how to really start with such a project and what's important and what milestones are important at the beginning. And definitely at the beginning, we need to go through one important thing. The phase is called data phase, or let's call it even pre-data phase. We need to answer the question if we have data, a lot of data for that business case, or if we are able to collect them. Once we say yes, that's fine, and we can then think if we want to automate a repetitive task or if we want to create intelligent system to get ahead to our competition. But without data, it's more difficult to start with, definitely with a deep learning. And once we have this answered, we can go to the second phase called data collection and labeling. We need to answer the question, what data do you need to collect and what data are you able to collect? Because there can be a big difference between these two things. And then we are going to label data, associate data with its representation. That's something that Richard explained on the example of cat and dog. We need to say the model that this is a picture of dog and this is a picture of cat in order to learn it. And then at the end of this phase, we are enabling machine learning models to learn complex data representations. And then we are start prototyping. And that's quite standardized process. We need to prepare and process data where then we can find some good machine learning models, some suitable ones. And that's the place where we can use AWS or Microsoft Azure clouds to help us with that. Then we train, validate, and test the model. And at the end of this phase, we have trained most suitable machine learning model we found. And still, we are isolated from the current solution. So we need to find the way how to create a pipeline between your current solution and our machine learning model. So we are going to find integration with a target application. And we need to find a pipeline how to do the monitoring of the model and retraining the model, because the model should be self-improving or partially self-improving to really get the best results possible. So at the end of this phase, we are creating the infrastructure and we are covering the complete machine learning pipeline from raw data sets to deployable machine learning model. So that's something we are advising to our customers, and even to help them more at the beginning, because there's like a huge amount of customers that are not sure how to really start with the machine learning. That's why we use a methodology that was invented by Google Ventures called the design sprint. The design sprint is a 5-day process for answering critical business questions through design, prototyping, and testing ideas with customers. It's good because it's all done before you invest time or other assets into building the product. Basically, you are finding the shortcut to learning without building and launching, as it's seen in a picture. And Google Ventures call it battle-tested process. The reason why they call it this way is that they have statistics that 9 out of 10 startups are going to fail. And that's why they need to find out quickly if they are good candidates for good startup or not. This process we use widely at CN Group for software and hardware development products, but we did not use it or have not used it so far for machine learning products. And the design sprint process has some challenge in the Monday morning and some learning on a Friday afternoon. That's standard process, standard design sprint process. But in case of machine learning, it needs to be slightly adjusted. And that's something we are working on right now. So we are creating the design sprint that includes three main pillars. The first is machine learning itself. The second is design process that is important for the process of design sprint in machine learning. And also agile philosophy. When we have these three ingredients to that part of design sprint, we are able to create design sprint for machine learning. We already tested on our internal product, and now we are starting with the first project with our customers, and it's coming soon. We are starting in November 2021. So that's all about the design sprint, how we can really start the project. And because we are at the end of our presentation, I would just like you to take, if nothing else, three thoughts from our presentation. The first is that deep learning is the most powerful subfield of the AI, and it won't change in following years. And there are like three main AI strategies for the business goals, and it's crucial to decide based on the business objective you have. Sometimes it's really fine to use something that's already on a market and you can just take it. And sometimes it's really worth it to use the time for creating something that is really unique for your business goal or business case. And as I just mentioned a slide ago, using design sprint to learn and fail quickly. That's something that can help the customers to better decide what's worth it and what's not. So that's all from our side. Thank you that you joined, and now it's time for questions and answers. If you have any question, please feel free. You can write it, or you can ask here. Feel free to use any channel you want. Okay, I will count to 10 silently for myself. All right then. If any question is coming to your mind later, you can find here mine and Richard emails. Please feel free to let us know if you have any challenge, any opportunity for machine learning, or you just need advice. Feel free to let us know, to write us, and we can discuss it later as you will want. Richard, thank you. I'm so glad that wind did not break our presentation as it happened. And thank all of you that you participated, because I know that during these COVID times there still is plenty of these webinars. And of course that time is important for all of us. So thank you for your attendance. And let's hope that I will see you once day live or any other opportunity to see you. Thank you, and have a good rest of the day.
Thanks everybody for your time. Bye-bye.
Thank you, Peter. Thank you, Richard.
Thank you very much. Have a nice day.
Bye-bye. Thank you. Thank you, everyone.
Yes, bye-bye. Thank you.
Bye-bye. Thank you.
Thanks.